Welcome to Lab 7, the holding circuit. There's two parts to this lab. There's going to be a quiz. You're going to have to be taking some measurements again throughout the lab. So I'm going to go over the two diagrams, and then I'll show you how to wire it up, and we'll just have some fun with this. This holding circuit is a very, very important circuit. You'll find it in a lot of safety circuits. Very punch presses, drill presses, anything with very large fans. Once the way that holding circuit operates is, if everything's fine, it will hold the circuit on, but if we lose power for any reason, the operator has to go check. I've even seen this circuit on a commercial steamer. It was on the combustion circuit, so that if they lost combustion for any reason, it would shut everything down, and it would also give a light to the operator. But back to the first diagram, which is not a holding circuit. Let's take a look at this. In your lab books, this is called diagram A. So it's all 120 volts. So we've got 120 volts coming in through the line. We're going to go into a stop switch. We're going to come out of the stop switch. If you push down on this stop switch, you push down here, it's going to actually stop. It's going to open up that circuit and stop the function. So this is a stop and start button, and this is the stop button here. You're going to come out of the stop, and you're going to go into the start button, and you can see here on the start button, if we push down, it's going to complete this circuit. We haven't. We're going to show all switches in the normal position. We're going to come out of the start, then we're going to go into the coil, the C1 coil, and then go back to neutral. The coil is going to be classified as a load. The reason for that is going to take that electrical energy and it's going to change it into a different type of energy. The coil is going to be a load because it's going to change that energy into magnetic energy, and it's going to use that magnetic energy to change to close these normally open contacts. Line 2, we're going to come in to the normally open C1 contact. We're going to come out of the normally open C1 contact, and we're going to go into a single speed fan motor, and then that fan motor is going to be a load. It's going to change that electrical energy into kinetic or moving energy, and we need to have a neutral here. And again, in parallel, we're going to power up a high speed fan motor, and again it's a load because it's changing that electrical energy into kinetic energy, and we're going to need to have a neutral going back here. So this is diagram A. It's not the holding circuit. Let's wire that up. And again, previous to this, I've done a 3-point check, so I know it's safe for me to work in this unit. So we're going to come here, line, we're going to come from the line, and then we're going to go in to, here we have the stop and the start. You can see this is normally closed, so we're going to come into the bottom of the stop switch. We're going to come out of the stop switch. Then we're going to come in through the bottom. So we're going to go into the start switch, and we're going to come out of the start switch. Now we're going to pick up C1 coil. We may as well choose this coil here because we do have two sets of 120 contacts. We only need to have one normally open, so we'll power up then then we'll take that neutral. So now we're going to come to the second line. We're going to come with our line and we're going to go into the normally. We're going to go into the contacts here. And now we can choose normally open or normally closed. If we look at the diagram, they're looking for a normally open. So then from the normally open, we're going to go to the single speed fan motor, which is down here. And that's going to be a load. It's going to be converting that electrical energy into kinetic energy. So we're going to need a neutral. And then we're going to come out of here again. And we're going to power up a high speed fan motor. So what we could do is use this. And then that's going to be a load, so we're going to need a neutral on that fan motor as well. Here we have power. And we're going to press the start button. And with me, with my finger holding that start button in, you can see both fans are running. And if I take my finger off, you can see that the start button shuts the power to the coil, and it takes the power and changes the closed contacts to normally open. If we try that again. Now you can see after probably an hour of doing this, the fun of this circuit is kind of lost you. So we want to be able to start and have that contact held in. Okay, so this is where this is going to be the holding circuit. If we go back to the diagram, what we're going to do, I'm going to place it here. And what we're going to do is we're going to come out of the stop and go into these other set of C1 normally open contacts, and then we're going to come out of them and we're going to go out of the start. Okay? And this is going to be our holding contacts. Let's take a look at it. What's going to happen here? So we're going to press the start. That's going to complete this circuit. We're going to power up C1 coil. That's going to close these contacts, and we're going to power up the motors. But at the same time, it's also going to close these normally open contacts. So these are going to be closed. When we take a finger off the start button, it has two routes. The power has two routes. It can go through the start button or it can come through here. So that should hold this coil in, and then this should be running. Now when we lose the power, here if we hit the stop button, we're going to lose the power there, and everything's going to go back to normal. So this is going to be your holding circuit. Let's go back to the board and we'll put in these two wires, and we'll take it from there. So what are we going to do? We're going to come out of the stop. So this is our stop button. So we came in through the bottom. So we're going to come out of the stop. Then we're going to go to the contacts in the C1 coil. We have our contacts here. Now we need to do normally open. So we're going to come out the normally open, and then it's asking us to go back in to out of the start. So this was into the start, this is going to be out of the start. So I'm going to push it in here. Well, let's see what difference that makes. So we've depressed the start again, and we've got the two fans moving. Now when I let the start button go, here we have those fans going on. For some reason, should we lose power, we've lost power, and then we regain power again, right? We've got people working on it, so that they've given power back to the unit. Nothing happens. We need to have an operator to go and check that everything's okay, and then once everything's okay and we're sure that it's safe to turn the power back on, then we can go back to that start button, and it needs somebody to physically. Here we have the holding circuit. The first diagram without the C1, the two normally open contacts, was just a circuit. That was diagram A, and in diagram B we only added in this small part of the circuit. That became diagram B. When you're going through the lab, we're going to be taking measurements with our meters. We're going to be looking around. Please make sure you're on the right diagram, right? Make sure your diagram A, you're answering the questions, and diagram B, you're answering the correct questions. Great. Good luck. Thank you.